Sathyabama Institute of Science and Technology.
Good morning all. I am Dr. N M Nandhitha, Professor and Dean, School of Electrical and Electronics Engineering, Sathyabama Institute of Science and Technology, Chennai. Today, we will be seeing how to write C program, especially if you are a biology student. So, biology student always has a mindset that irrespective of what, is it possible for me to write a program, especially when I am in engineering first year, having completed biology in my plus 2. So for such children, let me say, C programming is not that difficult. C programming is basically converting the English statements into max and then converting max into certain syntax based on whether it is C programming or Python programming or so on. At the end of the presentation, you will be able to solve these three different types of problems which I have written in this slide. Now let us go to the next slide. Here, for your sake, I have tried dividing the entire C programming into different types. So you see the first type which I have written as type 1. There are so many programs in any language irrespective of what where we use just only one line logic, and this one line logic remains the same irrespective of what. And the second type of problem statements do include series. For example, Fibonacci series. So for Fibonacci series, whatever the rule is same. The third term is the sum of the previous two terms and it goes on and on. And the next type, if you see it in type 2, we have given number patterns. Always we should believe something. That is a pattern between numbers. That is a pattern and no one can deny that there is no pattern. But the only thing is the pattern may be explicitly shown in certain cases and in other cases we have to find the pattern. Okay, but still always believe me, there will be patterns in the numbers and hence we should exploit that pattern and we can write a max formula on our own. Don't think writing max formula basically is very difficult for me. No, it's an easy max formula. We have to write it and then we can convert it into a program. Then next you have type 4 in which the logic is available. I will be calling this as wheel programs, which means that the programs are same. Even for me, for my grandchildren or whatever, the programs are always the same. We need not change the logic. We need not reinvent wheel. First, we have to identify these are the wheel programs and we will be using these programs wherever we want to. And last, the very easiest thing is the type 5 program where you can convert the problem statement directly into max. For example, if I ask you to find average of two numbers, you need not think you are writing a C program, but normally in max, if your max teacher is asking you to find the average of two numbers, then what you will do? Oh fine, I have studied the formula for average of two numbers and it is basically total divided by 2, right? Total is what? Again, total is an English word. That English word again we should write it as an expression. So total means what? Two numbers. So two numbers, can I have it as A and B? So therefore your formula becomes total is equal to A plus B divided by 2. Once you crack this formula, writing a C program is very, very easy. You got it? So that is what I have done in this slide and I have given you the various types of programs in which you can write C program. And here I have given you the first case and this is all about separating the digits in a number. And why have I chosen this particular example of all the programs? If you see, using this simple logic where we can separate the digits in a number, you can find out sum of the digits in a number. Then you can reverse the number. Then you can check whether that number is a palindrome or not. Then you can check whether the number is an Armstrong number or not. So you see there are 5 different programs but a single logic and that is why I have chosen this particular logic for you. So now the question is this: can you write a program in C for separating the digits in a number? Again, we have to think. Okay, so we have to write a program for separating the digits in a number. Have I studied any max formula related to it? Definitely no. There is no formula for separating the digits in a number. Then how can I do it? So now you have to think, I don't have a formula, but still I have to do it. So how to do it? Take a paper pen, write an example. If you do not know a formula, the only thing you have to do is take paper pen, write an example. And while writing the example, you try to write like this. If this is my input, what is the expected output? So let us also take an input over here. Let it be 567. So if 567 is the number, which is the input, now you want the output. the question is separating the digits. By separating the digits, the output will be what? First units digit, which is 7, then 6, then 5, right? So this is our aim. So input we have, output also we know what we want. Now, can we find a relationship between the input and the output? That is, I want units digit, I want tens digit, I want hundreds digit if it is a 3-digit number. So in max, how can I get the units digit? If I am giving the number, how can I get a units digit? Let us think, whatever may be the number of digits in a number. If you divide that number by 10 and if you are collecting the remainder, that remainder is obviously what? It's the units digit. So you see, I have given you the logic, not I. We all know this logic. So irrespective of a number, we have to divide the number by 10 and we have to collect only the remainder. So in 567, if you divide it by 10, see, we are not interested in the quotient. We are interested only in the remainder. When you divide 567 by 10, what is the remainder you will get? 7. So 1/3 of your problem is solved. So what I'm saying is, irrespective of the number, assume it as n. N remainder when it is divided by 10. In C programming, we use mod function, n mod 10, which will collect the remainder. So you should write an equation, R is equal to n mod 10, so that it will give you the remainder. So in the slide, you check whether I have written n mod 10. So come to the middle column where you could see in separating the digits, you are having one line, you see R is equal to n mod 10. So what is the use of this n mod 10? It divides the number by 10 and it collects the remainder, which is the units digit. Print it. We got the units digit. So what we have to do? We have to print it. So I have written printf %d, R. So here I want to say something. For every language, we have a syntax. So in C programming, for inputting, we usually use scanf statement. For printing, we use printf statement. So before writing a program in C programming, you have to first find out what is the syntax for these basic statements. So what all basic statements I have to know the syntax, if you see? You have to know for scanf, you have to know for printf, and all the iterative statements, looping statements. See, in C, you have 3 types of looping statements: for statement, while statement, do while statement, and then in conditional statements, if you are having if statement, if else statement, and then switch case statement. So better, the prerequisite before seeing my presentation will be, you learn the syntax for all these statements which I have said, or you can even refer a C programming book, get the syntax and you can write it. Okay. So our idea here is, being a biology student, how to think the logic and how to convert the logic into a C program. You got it? So going back, you had 567 as the number. That 567 when divided by 10 leaves a remainder, and that remainder is what? 7. And we have to print it. So you don't wonder why I have written printf %d, R. %d is for printing an integer number. So I have declared R as an integer. So I have written %d. This %d is called format identifier in C programming. You got it. So we have got the units digit now. Now we are left out with what? Tens digit and hundreds digit. So in 567, now 7 we have separated. So we are not interested in what we have separated. So what is remaining now? 56. In this 56, again if you divide 56 by 10 and collect the remainder, you will be getting what? 6, which is a tens digit. After getting 6, now we are not interested in 6 in 56. We are interested in 5. So again what we should do? That 5 should be divided by 10. 5 of course cannot be divided by 10. So the remainder itself is 5. So I am trying to explain a pattern to you. What am I saying is, you take a number, divide by 10 and then print it. After printing, discard the last digit of the number. Take the remaining. This is easy to say in English. In 577, you can discard 7 and take 56. But mathematically, how will you do? From 567, how will you get 56? Again, when 567 is divided by 10, what is the quotient? It will be 56.7. So we do not want 0.7. So do one thing, declare that number as an integer. When you declare the number as an integer, even if your answer is 56.7, it will take only 56. Is it clear? So 56 we have taken. So for taking 56, what did I say? Take the number, divide by 10. Okay, fine. You are dividing it by 10. You will be getting 56. Then repeat the process. Find out the remainder. You will get 6. Then take 5. Repeat the process. You will get 5. But we should stop right. The most important thing in any programming is finding a stopping rule. When should the program stop? So that stopping rule we have to find out. Again, let us see. Again, like finding it out is not a big deal, but we have to try a little with an example. So in 567, 7 we got, 6 we got, 5 we got. If you divide 5 by 10, what will be the quotient? Quotient will be 0. So when the quotient is 0, it means we have to stop. Otherwise, as long as the quotient is greater than 0, we can proceed. So I repeat, as long as the quotient is greater than 0, we can proceed. So as long as, which means proceed, iteration. So in iteration, there are 3 different statements which I said, do while and for. And in this example, I have used while. So you see, while n greater than 0, the stopping rule. And first thing I said, collect the remainder, r equal to n mod 10. Then I said print it. After printing it in 567, you have to discard 7. You need only 56. For that also I gave you a clue, get the quotient. So you see in C programming, to get the quotient is n is equal to n/10. So this is the logic. So this is the logic for what? For separating the digits in a number. So here I have given you one formula. This is also formula basically. When you want to reverse a number, integer number, rule is this. Positive integer number, if it has to be reversed, the rule is this. Sum equal to sum into 10 plus r. So what should be the initial value of sum? Sum is an additive identity. So sum should be equal to 0. That's it. So when you have to reverse a number, the logic which I have given here is sum is equal to sum into 10 plus r. So let us see the next slide. Here you see I have written the program, but in this program, while n greater than 0, open bracket, r equal to n mod 10, n equal to n divided by 10, which we have seen in the previous program. That is what I said. So what I want you to understand is, you can even keep it as a wheel program. Wheel program means the logic will never change. Whenever you want to separate a number, please understand while n should be greater than 0, r equal to n mod 10, and the next value of n will be n equal to n/10. In between these two, you can play. If you want to reverse the number, you have to simply write sum equal to sum into 10 plus r, and then you have to finally, after coming out of the while loop, you have to print the number. The reversed number is %d, sum. And here I understand that you should learn the syntax. You should be learning the syntax of the certain statements in C programming. Okay, or you can refer your C programming book, come out with the syntax initially. So the idea behind this presentation is, we need not panic even if we are a biology student, and even if we do not have a formula in maths also, you need not panic. Just write input and output. Try to find a relationship between the input and output, and after finding relationship between input and output, what you have to do, you have to convert it into maths formula and write it. Clear? So this is all about reversing a number, and you have to check. When I say something, you should not accept it is right or wrong. So you have to check. So in order to check, what you do while learning this, take a paper, give an example, check whether our formula is right. See, if I see all of a sudden, if I come and say sum equal to sum into 10 plus r is the formula for reversing a positive integer, you check whether I am wrong. So when you check by giving different test cases, different examples, you yourself will be confident with the same formula, and you will be advocating this formula to somebody later. Fine. So this is all about reversing a number. Okay, fine. Having reversed a number, can we write a program for palindrome? So what is a palindrome? Malayalam is a palindrome, right? Even when you reverse it, you get Malayalam. So if you want the longest palindrome in English, it is able was I, eraisa, elba. So likewise, you want to check whether a particular number is a palindrome. So can you give me an example for a palindrome? 565. So even if you reverse it, you get 565. So children, in this question, we have to, so here we have to check whether the given number is a palindrome or not. What is the logic here? Reverse the number. Having reversed the number, check whether the reversed number is the same as the original number, and if they are same, we have to declare them as palindrome. I repeat, first reverse the number, check whether the reversed number is the same as the palindrome. For reversing a number, I gave you a formula, sum equal to sum into 10 plus r. For separating the digits also, I have given you a logic previously, right? So let us come to this slide. In this slide, we have checked whether the number is a palindrome or not. In order to check whether the number is a palindrome or not, what did I say? First, separate the digits. For separating the digits, we have already learnt a logic. Then reverse the number. For reversing the number, I gave you a formula, sum equal to sum into 10 plus r. Then you have to check whether the sum is equal to that particular number, right? So three things I said. Let us see whether those three things are there in this program. See here, while n greater than 0, you are separating it. Then you are using this formula, sum is equal to sum into 10 plus r for reversing it. Having reversed it, you are checking whether that sum is equal to temp. You may wonder what is temp. I have a copy of n. In temp, you see, I have stored temp equal to n. You should ask me a question. Why, ma'am, unnecessarily you are having the value of n over here? Because in my logic, I am changing the value of n. Initially, n was 567. I am not denying it. Later, I am changing n as 56, then n as 5, right? So, we want the original number. So, I am having a copy of the original number in temp, and finally, I am checking. If sum is equal to temp, then it means it's an integer palindrome. If not, it is not a palindrome. Fine. One more also I promised you, right? Whether it is an Armstrong number or not. If it is a 3-digit number, what is an Armstrong number? If the sum of the cubes of the digits is equal to that number, then it is an Armstrong number. I repeat, if the sum of the cubes of the digits is equal to that number, in a case of a 3-digit number, then you can call that number as an Armstrong number. Here also, are you hearing the word digits? When you hear the word digits, what you have to do? You have to separate the digits. For separating the digits, what is the program we have written? While n greater than 0. So, same logic you see. Then I said, right, for Armstrong number, sum of the cubes of the digits. So, cubes of the digits means r into r. So, sum equal to sum plus r into r. Here also, to have a copy, we have to have that number. So, temp. So, if sum is equal to temp, then you should write it is an Armstrong number. If not, it is not an Armstrong number. So, with this, I am concluding the presentation saying that if you know one particular logic, then with that logic, you can come out with different solutions by using the same logic anywhere. And here I have taught you a case in which we are not having an inherent implicit formula for this, but still you can crack it. Okay. So, thank you all. Thank you.